Welcome back, class. Thanks for tuning in. Let's jump right into it. So we're going to be going through our Week 9, Part 3 Google Form answers today. This is our last week of the year, so congrats to all those who are actively participating each week. But let's jump right into the iPad and let's kind of look at each problem here. So, all right, so what you're looking at here is the iPad. Week 9, Part 3s were on logarithms. I promised the previous week that we kind of go over a little more easier examples to make you kind of more comfortable with this stuff. And again, maybe if you're going on to Calc next year, this will be a topic that we still cover, so don't feel like you're going to be lost completely. But let's jump right in and let's take a look at our first problems. I think I have 5 problems picked from the Google form, and we're just going to kind of walk through each one. Probably using my own calculator. I mean, I can pop up the one on the screen, but it might be just easier for me typing it in. We'll see how this goes. So first one here, so we need to write this in exponential form. So we don't even have to solve anything, we just need to rewrite it. So the trick for doing this is to do a circle method. That's the trick. So we have a base of 4, and what a logarithm is equal to is the power. So the -2 is the power. That's the power that you're putting on the base. And then that's equal to the number that's right next to the base number, which is the 0.0625. And hopefully that makes sense, because the idea here is that when you put a number to a negative power, it's dropping it down below in the fraction. So that hopefully made sense. But let's keep working here. That's the first one. Let's go to the second one here. All right, second one. We have to write this in exponential form again. So we have a base. We're putting it to a power of 7, because again, that's what a logarithm is equal to. It's equal to the power that you put on the base, and that's equal to the item that's next to it. Okay, and that hopefully makes sense. 3 to the 7th power should be 2,000. Let's check to see if they're actually accurate. They are. Okay, let's go to the next one. What is the value of log of base e? Now, log of base e, what that is, this is the same thing. This item and this item are the same. This log of base e is the natural growth number. It's how bacteria and population growth says, as like one rabbit has 2 rabbits, and those 2 rabbits have more rabbits, and it just kind of exponentially grows faster and faster and faster. This is the button we're going to type in a calculator. Now I'm going to jump right to my computer screen, because my computer does have a natural log button, which I think will be actually helpful. So what you're looking at here is my calculator in front of you. I'm going to type in my numbers into this. So I'm going to hit the 5, and then I'm going to hit the natural log button. And that number right there, that 1.60 number, that's this number. 1.6094. That is the number. That's the power you'd put on e to make 5. Now, if you don't know, let me clear up my calculator here. E, just the number e is 2.7. That's the growth. One couple has, can produce 2, and then 2 can produce, more and more and more and more. And so when you put this number to a certain power, so I'm going to put it to the power, so x to the y key. I'm going to type in 1.6.6094, and this is a decimal approximation. It's about 5, 4.999, as you can tell. So it is accurate. Let's go to, we got 2 problems left here. We need to write this problem in exponential form. So let me jump right back to my iPad here. All right, let's jump right back to the iPad. All right, so we need to write this. So I'm going to rewrite this as this, 0.0016. All right, so circle methoded up. So the log of this base of 0.0016 should be equal to the power that we have on it. Again, a logarithm is equal to the power you're putting on the base. That's the idea. And that's what they're looking for. That's logarithmic versus exponential. The original problem was exponential, and I changed it to logarithmic, because maybe you're trying to figure out the power that you're putting on that to make 0.0016. All right, last problem here that we have. We have the value of log of e. So log of e, this is the same thing as the natural log. That's the same thing. That's what this means. It's the same idea of 0.25. So let me jump right to my calculator here. So we're going to type in that 0.25 and then hit the natural log button, the ln button. And that gives me the power, so negative 1.38629. And hopefully that makes sense. You're trying to put a power on e, 2.7, right? That's roughly what e stands for. That will make a smaller number. And so you had to put a very small power, a negative, so it makes it a fraction. So it makes it down to 0.25. So that's what this is. That was our last problem. I know that doesn't seem very much, but it was just one of those things. I think it's important that we get to see, how to do some of these problems together. Next year we'll continue with logarithms as a big part of calculus. So if you're taking that, or maybe you're going into statistics, it is a part of it. So it's one of those things I think is important. But again, thank you for all those who are actively participating, and hope to see you guys real soon.